Welcome back to another video on my channel. Today we will be talking about some of the most basic trig integrals of all the fundamental trigonometric functions. So without further ado, let's move on to the video. The first few integrals we will be talking about are about sine and cosine of x. So let's start with the integral of sine of x. Now this integral is equal to negative cosine of x dx, or sorry, not negative cosine of x dx, negative cosine of x plus c. Now, how do we know this is true? Well, let's differentiate both sides of this equation. So the derivative of the integral is just sine of x, and now since we know that this is negative cosine of x, so d by dx of negative cosine of x, and we know that the derivative of cosine of x is negative sine of x, so negative of negative is equal to positive. So this equation becomes true and the integral is proven. Something similar can be said for the integral of cosine of x dx. Now this is equal to sine of x plus c, and when you differentiate both sides, it becomes again a true equation. So if you want to know the full steps, you can do it yourself so you can learn more about this. So now that we've done with the most basic ones, what about the more complicated ones? Now let's start with the integral of tangent of x. Now, tangent of x dx, we can rewrite this as sine of x over cosine of x dx. And we can say cosine of x is equal to u. So negative sine x dx is equal to du. So now that we have that, we'll have negative of du by u, and then integrating that, we get negative the natural logarithm of cosine of x. Or since if you watch my last video, which you really should, you'll know that the integral of du by u is equal to natural logarithm of u, and this is equal to negative ln of u, and since you use cosine of x, we plug that back in. Now, if you know your logarithm formulas, you'll know that the negative ln of any function or anything is ln of 1 divided by that. And 1 divided by cosine of x is secant of x. So this becomes the natural logarithm of secant of x plus c. A similar thing can be done with the cotangent of x. What happens over here is we have cosine of x over sine of x dx, and this becomes, we have sine of x is equal to u, and cosine of x dx is equal to du, so this again becomes du by u. This becomes the natural logarithm of u, or just sine of x. So now that we've gone through 4 of the trig functions, now one more thing before we move on to the final 2. I need to talk about 2 more integrals. Now these integrals are, first, the integral of secant squared of x, which is equal to tangent of x plus c, and you'll know that if you differentiate both sides, since integration is just the opposite of differentiation. And then we have the integral of cosecant squared of x dx, and this is equal to the cotangent of x plus c. So now we figured out the method to differentiate both of these by just integrating both of these by differentiating both sides. Let's move on to the final 2 integrals. The first integral we will look at is secant squared, just the integral of secant of x dx. Now, we will employ one very, very useful trick, and that useful trick is to multiply and divide by secant of x tangent of x. So secant of x multiplied by secant of x plus tangent of x divided by secant of x plus tangent of x. Then we have dx. So now what we can do is we can expand the numerator. So this gives us secant squared of x plus secant of x tangent of x divided by secant of x tangent of x dx. And now you're like, wait, what? This looks so much more complicated than our original integral of just the secant of x dx. But as you'll see, this will simplify beautifully to a very, very nice function. So what we can do is we can do secant of x plus tangent of x is equal to u. And if we differentiate that, du is equal to secant squared of x from differentiating tan of x plus secant of x tan of x, and that is going to be equal to the secant times dx is going to be equal to du, and as you can see, that's where our integral is. So now you also know from this that integrating secant of x tangent of x is going to give you it's going to give you secant of x. So that's another trig integral you can add to your basket. So now that we have this over here, we're going to get du by u, which is just ln u, and plugging back u in, we get the natural logarithm of secant of x plus tangent of x, all absolute value, which is true for all of the natural logarithm functions, as you can't have a natural logarithm less than 0. So now we have this plus c. And that's pretty much about it, what's going to happen over here. So that's very, very efficient and a beautiful method to solve for this integral. Now, look at what I saw earlier. This integral over here, cosecant of x dx plus cotan is equal to cotangent of x plus c. Now, my challenge for you today is to figure out the integral of cosecant of x dx. The same method will be used where you have a clever addition or subtraction involving cosecant of x and cotangent of x, and it will also turn out to something very, very simple, like the final answer for this problem. So, good luck to try that. Thank you so much for watching this video. If you enjoyed, please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. And I guess that's about it. See you in the next one. Enjoy, and bye-bye.